Hello friends, welcome to another technical video. It is the third part of our topic, isolator, switch and circuit breaker. In this session we will be discussing about different requirements to be complied by a device to act for isolating function. Here some applications are also explained. Actually, all we know about isolator, moreover, I explained in my first part some basic definition for isolator, switch and circuit breaker. But in this session, I will be giving more deeper informations about isolator. It will be very much useful for many practicing engineers. Actually, I am not explaining anything from my pocket. Just explaining you what is said with our regulations and other BIS standards. If you have not yet gone through the first two parts of this topic, please watch the videos in my YouTube channel. If you are finding this information useful, please share with your friends and also subscribe to my YouTube channel and support me. Okay, let us move to the topic. Today the topic is isolator, switch and circuit breaker, and we will be explaining today in detail about the requirements of a device to function as an isolating device, or we will be discussing more, or we will be discussing in deep about isolator. And see here you can see two terms, isolator and disconnector. I explained in the first part about these two terms. These are the basic terms only, and we are intermittently using these two terms. Isolator and disconnector represent the same, and you can see the graphical symbol here. So what is an isolator? Isolator means the purpose is to keep a circuit isolated for some purpose, just like a maintenance or something like that. The isolation of the circuit should be guaranteed. That's a requirement. That much assurance will be given by an isolator. Means the circuit will be, the opening will be visible or some other conditions are there. So isolator means it is an entirely different one, not like a switch or circuit breaker. The importance of the isolator is very much essential. Here you can see the definition as per this IS. It is a mechanical switching device which should comply with some requirements in the open position. Means when the device is in the open position, there will be some requirements as explained below. Here you can see two conditions. Actually these two conditions I already explained the first part. The device should be able to open or close a circuit when there is negligible current or no current, or when there is negligible voltage in between the terminals. Means the isolator should be able to operate in off condition, means off load condition. That's the first condition explained. And in the second condition, suppose the plant is functioning the isolator is there in the circuit itself, then it should be able to carry the current running. The current means either it can be a normal current or an abnormal current in some abnormal situations like short circuit or overload. So it should be able to withstand the load current and the abnormal current. Abnormal current means for a period of specified time, for a particular time, and after that time it will be tripped, means some protection of the protection device of the circuit will be operated. So isolator means it should be able to withstand the current for a specified period if the current is abnormal one. See, this one also I explained. Actually, isolator means the isolation of the circuit should be visible to our eyes. It should be, we should see the circuit as open. But in some cases, like the case of circuit breaker, the opening cannot be seen with our eye. So in such cases, instead of the visual isolation, some indications like shown here, O for on or O or I, such indications will be enough. So that is explained in this IS. And see here the underlined portion showing this indication means such indication shall only occur when the isolating distance between open contacts or each pole of the device has been attained. Means I will be showing a figure in the last. It is actually the mechanical portion inside that device will be a single piece and it will be moving as a single unit. Means that if we are seeing the indication there, certainly the circuit will be opened. That's the meaning. And next condition, see here, isolation. What is the requirement here? The device should isolate all live conductors, but it should not open the PEN conductor in case of TNC system. The PEN conductor, protective earth neutral conductor in TNC system, or it should not open the neutral conductor in TNS system. Means the isolator or the purpose of the isolator is to open the live conductor only. See here, as per this IS, isolator should get certificate for 2 lab tests. See, in the first case, we are applying some impulse voltage across the terminals in open condition of each pole. Means in the open conditions here, in the open condition, we are applying some voltage in between these terminals of a pole, and the voltage is impulse voltage. Then the isolator should be able to withstand that impulse voltage. That's the first condition. And in the second condition is about leakage current. Means here we are applying an voltage 110% of the rated voltage of the device. And when this voltage is applied, there will be some leakage current in between the terminals. This leakage current should be within the limit of 0.5 milliampere if the device is new, clean and in dry condition. That's the first condition. And suppose the equipment is running for a long time or it is an old one, then in such condition the leakage current can be considered up to 6 milliampere per pole. That's a second lab condition. See here some additional requirements also there for the device. First condition is semiconductor devices should not be used for isolating device. Semiconductor means a solid state. As I explained earlier, the isolation should be visible or some indication should be shown there. So semiconductor, in case of semiconductor devices, it will not be possible because we know solid state relays. The opening cannot be seen. So in such cases, or for the function of isolating devices, semiconductor materials should not be used, or semiconductor devices should not be used. Another requirement is unintentional closure. Means suppose the isolator is functioning in a circuit, some vibration or shock may be there. In such condition, the isolator should not be opened itself. Means it should be designed in such a way that there will not be any unintentional closure due to shocks or vibrations. That's the next condition. Then another condition is unauthorized opening or inadvertent opening should not be happened. Means suppose an isolator is functioning in a circuit, some unauthorized person is coming and opening it. It should not be happened. That is what is explained here. So for that, the isolator should be, either it should be kept in a lockable space, or it should be locked with a padlocking system, or there can be some interlock. Interlock means suppose the isolator is connected with some circuit breaker. There can be some interlock between the circuit breaker and the isolator. Means only after opening the circuit breaker, the isolator should be able to operate. That's a condition. Then another condition is the isolator means it should be clearly identified. Wherever the isolator is coming in a plant, it should be clearly identified, and the circuit also should be identified, perfectly identified. Example, marking or something like that should be clearly marked. Okay. Then in some cases there will be suppose in a plant there are some inductive load or capacity load. We are going to open the isolator after the plant is off. But because of the inductive load or capacitive load, there can be some stored energy. It should be bypassed, or some earthing switch or something like that should be provided there to bypass the stored energy. So such arrangements also should be provided there. Okay. Now we are explaining some regulatory clauses in which the function of isolators are explained. See here, regulation 45 of our safety regulation. See here, it is said that isolators or controlling circuit breakers need to be interlocked each other, and in some other cases the isolators need to be interlocked with earthing switches. In substations it is usually required, and it is needed to do the interlocking in between them. See here, this circuit breaker should operate first. For that, the key should be taken out from that circuit breaker, and then only with that key we can operate this isolator. That is the requirement. That is explained in regulation 45. See here, the regulation is technical standards for connectivity of the distributed generation resources regulation 2030. Means it is related with solar energy or something like that. See here, it is said that with such circuits, suppose if it is a solar circuit, there must be a manually operated isolating switching device in the circuit to operate by the licensee person. Means when they are planning for some maintenance in their lines, they need to open all the nearby solar circuits, and they will be using this isolator, and they will be opening it, and it will be locked by padlocking or something like that. So first condition is there should be a manually operated isolating switch. Means there must be an isolator and it should be manually operated. And see here another two conditions there. First one is allow visible verification that separation has been accomplished. What is the meaning? Visual isolation. And what about the second condition? Include indicators to clearly show open and closed position. Means either the first condition or the second condition should be achieved. That's the inner meaning. So either it should be visible, visually able to see the separation. Otherwise, some indications like in circuit breaker. Means what is the meaning? You can use here an MCB isolator. Okay, MCB isolator is also can be used for this purpose. That's the meaning. See, another point here I want to say is, see in the condition D, be capable of being locked in the open position. Means the licensee person should be able to lock the isolator. Then another point is the isolator should not have, the device that you are using here should not be load break or should not have the features of overcurrent protection. Means the pure isolator itself should be used. It should not be misplaced or misinterpreted with a circuit breaker or switch fuse unit or something like that. It should not be used there. A perfect isolator should be used in the circuit for this particular regulation. See, suppose some authorities are giving you direction that some circuit breaker is enough there. Circuit breaker can be having some isolation duty, but it should not have the overcurrent protection. It should not be load break type. It must be a perfectly isolation with isolative feature. That's the point here. Another application I am explaining is about National Electrical Code Part 1 Section 11. Here it is explained about firefighting equipment. See, for the firefighting circuit, there must be some isolator and there should not be any overload or no voltage protection with the circuit. Means their isolator should be included in the circuit. That is another application of isolator. See, here you can see the indications O, off, or in the other position you can see I or on. And see, these are the notations for isolator. It is a conventional type isolator. See, here you can see the indication here. This is the isolator. See here, it is a sectional view. Here you can see it is a single piece. Means it is moving independently. Means if it is moving to off position, it is sure that the isolator will be off. That is the guarantee that we are getting. Okay. Now, anyway, now I am concluding here. I explained about isolator. Isolator. What is isolator? What is the purpose? It is for many applications, as I explained, and there are many requirements. And there are some lab conditions also. Applying an impulse voltage, it should be able to withstand. The terminals of each pole should be able to withstand the impulse voltage. And the impulse voltage is in kV range. And another one, applying 1.1 times of the rated voltage across the terminals. Some leakage current will be there. If the device is a new one, it should be in the range of 0.5 milliampere, and if it is an old one, means if the isolator is running for a long time and just to one test we are doing it, then the leakage current can be coming up to 6 milliampere, means up to the limit of 6 milliampere is permitted. Okay. In the next part, we will be explaining some more about this topic, isolator, switch and circuit breaker. And today I am closing this section. If you are finding this information as useful, Please share with your friends and kindly subscribe to my YouTube channel and support me. Thank you for your patient listening. Thank you.